to talk about volcanoes. Who here knows about Krakatoa? Any kids? Who can tell me about Krakatoa? East of Java.
Yes?
It was the loudest ever volcano explosion.
Excellent. Good fact. Yeah. Excellent.
How far? Do you know how far away they heard the bang?
Was it like 2,000 miles?
I think.
Yeah, that's what they think. Something like 2,000 miles. Something like the distance from, if you're in Ireland, hearing an explosion in the east coast of the US, like Boston. So that's quite impressive, isn't it?
It just totally blew up. Do you want to meet someone who stood on top of Krakatoa? Meet Mike Cassidy, who's a volcanologist. You stood on Anak Krakatoa.
I have actually.
Oh, we got a picture.
There is we didn't plan that. That was. Yes, that's me standing on Anak Krakatoa in 2017. And actually, this is kind of the. Shall I stand up?
Yes.
Is that better? Yeah.
Yeah.
So this is a lava from Anak Krakatoa. So these are the lava rocks that erupted from that particular volcano. And then a year after this photo was taken, so I'm standing on the island in the middle of that really explosive eruption that happened in 1883, the one that you were talking about, that really bad bang. But then, and that made that huge, what we call a caldera, huge crater. And in the middle of the crater, since the 1920s or so, there have been this kind of smaller volcano, what's called the Anak Krakatoa, and it just grows kind of by successive eruptions, small eruptions, and it formed this little island called Anak Krakatoa, which in Indonesian means the child of Krakatoa. But then the year after this photo was taken, because these rocks are some of them are hard, but some of them are very kind of ashy-like, that collapsed into the ocean and caused a tsunami. And we weren't aware that it was going to happen. We didn't know it was going to happen, and actually killed about 450 people on the coasts of Java and Sumatra.
So.
Yeah, sorry, yeah.
No. So there you have Mike Cassidy. Who knows what volcano has been in the news recently? What country? Yeah?
Iceland, I don't know exactly what it's called.
Iceland. Well, if we can switch off the pictures, we can be joined by, on your right, on my left here, please say hello, Freystein.
Hi there. Thanks for giving me the opportunity to join here from Iceland.
Okay, and what's the name of the volcano that's erupting not far from you?
Where the magma accumulates, we call it Svartsengi, but the town that is affected, the name is Grindavik, and the eruptive fissure that is erupting is called Sundhnjúkar. So pick your name.
I'm not very good at Icelandic, I'm afraid. I've been to Iceland, and the whole place is just volcanic rock everywhere. Do you ever get bored, Freystein, of all the volcanoes you have?
Yeah, well, we are bored now when it is affecting people, when people are influenced. But before people were influenced, we were enjoying them. We have lots of benefits from volcanoes in Iceland. Geothermal activity is powered by volcanoes, and hot water, geothermal water, we heat all our houses with geothermal water. But then we have the negative sides when people are affected, like now, in this activity period in Iceland. It provides new challenges for us. We have had like a playground for volcanology now for a few decades, where nothing serious has happened, but this has had a big influence, and the evacuation of 1% of the population of Iceland from this town of Grindavik.
Yeah. And on your, well, you can't tell possibly, on your right is Jenni Barclay. Jenni, you're from Bristol University, but you're not from Bristol University at the moment. Where are you?
Yeah, so I'm not at Bristol University. You can see in the background maybe, very beautiful. I'm in the country of Guatemala, which is a very volcanic country. And at the moment, there's a large conference of volcanologists coming together to talk about the latest research. And we can see erupting, it's probably erupted since we began this session, the volcano of Fuego.
Fuego, fire, is that right?
Mm-hmm. That's right, yes.
I've talked about that on my program. That's quite a regular
yes.
threat, I think.
So Fuego has a very, what happens with volcanoes often, of course, is they have variations in the size of eruptions. This is a really big challenge for us when we live around volcanoes with the communities. And Fuego had a large eruption that you might remember, Roland, in 2018, that very unfortunately killed quite a few people in a village from a pyroclastic density current.
And that's when stuff is rushing down, the ash and stuff is rushing down the slope of the...
Absolutely. It's when material comes out very fast, but then it's so heavy that it collapses down the hillside and moves down the hillside in a glowing hot avalanche of rock and gas and ash. And because of that gas, it makes it move relatively quickly, and they are very difficult to get out of the way of, and not something that you can survive being in.
And you're at this conference, Cities on Volcanoes, so you have experts from all around the world, is it, with you at the moment?
Absolutely, yes. I guess in Iceland we're very busy right now, but we have experts from all the countries around the world dealing with these problems, and they come together to try and share our ideas and develop ways that we can do even better in the future.
Just one thing, you said you could, if you turn the camera around, can we see this El Fuego?
No, I tried to put myself where that was possible, but no, but you couldn't see.
How close are you?
Sorry?
How close are you?
How close are we? We're probably about 10 kilometres away, 10, 20 kilometres away just now. It's a beautiful day. Let's see if I can turn the camera around. There we are. Here we go. I suspect it's maybe a little bit nicer. So this tells you something about some of the wonderful benefits. Many places where we live with volcanoes, like Iceland, are extremely beautiful, and they bring benefits like fertile soils and also energy. So it's extremely important that we understand how to live alongside volcanoes rather than just imagine that we have to all just move very far away.
And that's an interesting point. So, Mike, what's the closest volcano to us? Is it Freysteins, or is it, I don't know?
I think actually it's probably closest volcano to the UK is probably either in Germany. Ooh. So we have a large eruption that occurred about 13,000 years ago in the Eifel area in Germany, in West Germany. But the closest maybe active one that is probably Italy as well.
Yeah. I think it depends where you live in the UK, remarkably, Mike.
Really? I didn't know that. Okay.
You belong in the Shetland Islands. You're very close to Iceland.
Oh, true.
Yes. How many? I mean, we've been talking about what's happening near Grundavik in Iceland, but how many? Do you know how many active volcanoes, how many ongoing eruptions there are at any time?
Oh, I've got an app on my phone. I should have a look. But almost at any one time, we might have as many as sort of 7 or 8 or even 15 volcanoes that erupt in some sort of small way. So Jenni talked about Fuego volcano, and that's just one of the volcanoes that has these kind of very small eruptions, explosive eruptions, but very small. You might have seen the photo that I came in on, and there was a small eruption from a volcano called Colima in Mexico. So there's kind of small eruptions that go on quite frequently around the world. And then, of course, Iceland's been picking up quite a lot recently. 5 eruptions in quite small space of time. So I would say it's about that amount.
Freystein, these eruptions down in southwest Iceland, quickly talk us through. They started about, 3 years ago? Is that right?
Yeah, and they have been very comparable to the most typical volcanic activity when we have in Iceland. We call them fissure eruptions. So fissure of a few kilometers of length, where liquid magma, the molten material inside the volcano, comes up to the surface, and we call them effusive, meaning it is lava liquid that comes up and flows along the surface of the earth. So it is not broken into ash and it doesn't go up into the air. So it is mostly flowing along the ground, lava forming eruptions. And we have had 3 now in the last 3 months, so 1 every month, very short, but they are dangerous because they start quickly and they have caused damage here. We also are dealing with problems in this town of Grindavík just by surface cracking. So we have a lot of magma flowing in the subsurface as well because we are at the plate boundary where 2 of the major plates of the Earth are moving apart. This causes, in essence, a space problem. So we need new magma-filled cracks to fill in. And even if activity is all in the subsurface, there can be cracking and faults at the surface. That has been the main reason for the evacuation of the town of Grindavík. But the eruptions, lava forming, fissure eruptions, few kilometer length, quite typical for Iceland activity.
I mean, it's interesting. You won't have heard because of the audiovisual system here. We were talking right at the beginning with Mike about the enormous explosion of Krakatoa, 100 and whatever it is, 40 years ago. And we can understand why that's dangerous, but I'm really curious because these are quite small eruptions, but they are extremely troubling for you in Iceland.
Yes. Indeed, they are. So we have there are 3,000 to 4,000 people that needed to evacuate the town of Grindavík. That was mostly for magma flow inside the ground, no eruption even. But now there is additionally danger of eruptions, and they are hazardous because the lava flows they can just There are very few precursors, so it can be down to, for the last eruption, it was half an hour. So with a very short notice, we have a crack that is a few kilometers long, forming, and it opens up, and there is a lava flow, and it was moving rapidly. Last week, eruption caused a destruction of roads, but more importantly, of a pipeline carrying hot water to heat houses of more than 10,000 people in a nearby area. So there was no heating of the houses here in the winter time, and that was very serious. So we are sort of trying to adjust how we live with our modern society when we have infrastructure that is critical. There can be destruction to roads, escape routes for people if they are living close to a volcano, and electricity, hot water, etc.
And I think that's particularly, I want to get on to, as it were, the kinds of hazards we might not necessarily think about with eruptions, because there's a dramatic bit, but there's actually an awful lot more goes on. I just want to ask one more thing, Freystein. I think you've told me before, this is an area that it was not active for about 800 years. So this is a new cycle of activity in an area which has been basically inhabited by Icelanders for most of Iceland's history, which is now changing.
Yes, that's correct. We know all volcanoes are episodic. So why do we have volcanic activity? There is heat inside the earth that is melting rock, and we need to bring the heat to the surface. But this delivery to the surface is very episodic. And in particular, in this area in South Iceland, we know from exploring geology that there are periods where things are quiet for maybe up to 800 years, as the period that ended a few years ago. And then we may have a century or two where there is a lot of activity, and we are coming into such phase now. And what is special about Iceland is because of the plate spreading, we have the plates moving apart, and therefore we build up a lot of force in the crust, and that is having a big influence determining where the fissures occur and the style of activity, indeed these long fissure eruptions.
I mean, the main city in Iceland is Reykjavik, which is where you are.
Yes.
It's not that close, but is in the next 50 or 100 years, could Reykjavik actually become, severely destabilized, shall I say, troubled by this activity?
It can be troubled, but not in the same manner as Grindavik, maybe, because Grindavik is right in the main danger zone. Sort of, we have some parts of the city of Reykjavik, some outskirts of Reykjavik or suburbs that can be influenced by fracturing and lava flows, actually, but most of the activity will probably be out of Reykjavik. But on this time scale, if you want to see through what happens in the coming time scale of decades or a century, there can certainly be influence. So now is the time to prepare, and maybe the situation when we run into a problem like having a town in a danger zone because of natural hazards, we can ask the question: could we have done something differently in planning how we utilize land or make new buildings? And there will be some issues for Reykjavik, but hopefully not excessive.
Mike, hoping Jenni will be able to rejoin us. I'm sure she will. One of the reasons I wanted you to come here is it's perfectly understandable why people living in Iceland, on top of an entirely volcanic island, or where Guatemala, where Jenni is, people living right next to earthquakes have to learn how to. Volcanoes need to know how to live with them. One of your things is that even though we're in the UK and there's nothing like that around, the volcanoes are something we need to think about too.
Yeah, certainly, and we're talking about a different scale almost of magnitude of eruption or size of eruption than what Freystein's been talking about in Iceland, and also different sort of time period. So not on the order of several years in frequency, but also perhaps kind of every 500 years or something like that. And this is quite important because although these are fairly low frequency or low probability, if you like, if it does occur in our lifetime, then there will be serious consequences. And that's something that I don't think the world necessarily is preparing for, that sort of eventuality.
I mean, we talked a bit about Krakatoa and the fact that pressure waves went all the way around the world, I think 2 or 3 times from that explosion. There's another one, is it Tambora in 1815?
That's right, yeah.
Which led to the year without a summer.
Yeah. So what happens with these really large eruptions, and Iceland also has its fair share of historical eruptions that have affected Europe and also wider areas. The last one, I guess, Freystein would be 1783 in Laki.
Yes, exactly.
And that had huge consequences for not just Iceland. I think it led to a reduction in Iceland's population. About maybe a quarter of people in Iceland lost their lives.
Yes.
But over Europe as well, because all these gases were emitted, that kind of sent a fog over to Europe and caused kind of problems with agriculture and problems with people breathing in that fog, that acidic fog. But not only those sort of Icelandic eruptions, the fissure eruptions that Freystein was talking about, but we can also have these explosive eruptions like Tambora in 1815. And the year after was called the year without the summer. And even though this eruption happened in Indonesia, in the UK, I don't know how many thousands of miles away we are from Tambora in Indonesia, but we were finding that the year after, 75% of our agriculture was reduced because of that eruption.
So, sorry, the weather was changed?
Yes. So what happened in that incidence was that we had huge amounts of gas being erupted into the upper atmosphere. So things like sulfur gas that goes into the upper atmosphere, it reacts with water and it forms this kind of what's called an aerosol. And that aerosol bounces the solar's radiation, the sun's radiation, back into space. So that has an effect of basically cooling the Earth. So we're talking about 1 or 2 degrees was cooled about 6 months after that eruption and lasted sort of about 5 years. So if you compare that to anthropogenic climate change, which is our temperature at the moment. Our global temperatures are increasing about 0.3 degrees per decade. We're talking about a cooling, so the other way, but very quickly. So 1 degree, so much bigger, 1 to 2 degrees, and within about 6 months. So there'd be catastrophic consequences with agriculture, with extreme weather, monsoons, and other types of weather systems.
And we've got questions all around. Yeah, I'm going to let you ask first.
I heard there's a volcano that might erupt recently in like Italy or somewhere, and if it erupts, it could cause a volcanic winter here.
Yes, yeah. So you're probably referring to the Campi Flegrei volcano, which is based. It's the less famous volcano in Naples. So Naples has Vesuvius, which is the nice kind of towering mountain above Naples that caused the destruction of Pompeii. But actually quite innocuous is the volcano of Campi Flegrei, which is this very low-lying volcano, but it actually has had really explosive eruptions in the past. So it's a volcano that's quite hard to monitor. It keeps on going up and down, and lots of these big volcanoes have this very kind of like what's called restless volcanoes. They can't sit still. They keep on expanding. There's earthquakes. So often they might show signs of earthquakes and uplift, but nothing happens. So we don't really know what's going on there at the moment.
But I think what's really interesting about that one is that, you know, basically this is on the edge of Naples.
Yeah.
I mean, the whole of, I wish Jenni was here. Come back, Jenni. Because this is, I mean, of all the places to build one of the biggest cities in Italy, the whole thing is sort of either next to or over on top of a volcano, which has been totally explosive in the past. But presumably, it's not because people are stupid. There's reasons to build there.
Yeah, there's lots of reasons to build there, and Freystein and Jenni talked about those. And also, it's not just a problem if it erupts, because there's a problem if it doesn't erupt. Also, you know, the problem of evacuating 3 million people if they need to, the problems of, you know, if Grindavik, if you think of that as a very small scale kind of site where we're seeing huge problems, and maybe Freystein can talk more about this, the fact that perhaps the lava hasn't damaged only a few people's homes, but actually that the fact that they've been evacuated has caused big problems for that general region. I don't know if you want to talk about that, Freystein.
No, I'm happy to talk about that. It's a big issue. Well, there are cracks in the surface, so properties have been destroyed by cracks, and there has actually, unfortunately, been one death by a worker who was trying to prevent more sort of hazards or damage from these fractures by filling in a fracture. But as soon as people need to move away, few thousands, there's a big issue. And for us, it is 1% of the population, and it is devastating. And we actually don't know when these people can go back, or business in this town. We need to see. The problem is that we don't know how long this activity continues. So there is pressure increasing in the ground close by this town due to inflow of new magma, and there may be more activity. So here there is an uncertainty phase that is also very sort of difficult to handle, sort of. What should people do? Do we all, does everyone stay out of this town for years, or do we use this property? What is acceptable risk?
Yeah.
The key question that the civil protection is trying to answer together with advice from the geoscientists.
I mean, was there any reason why Grindavik is where it is? Because I have a vague recollection of seeing some aerial map that showed that it was on one of the pre-existing fissures or something.
Yes. Yeah, and it's the same with Campi Flegrei. There are many reasons people go to these areas. They can be beautiful. In Campi Flegrei, I mean, geothermal resources, people in Italy were using them, but both for Campi Flegrei and Grindavik, the reason for the town and village is the same. Good harbor. The Roman Empire had their fleet there in in a good harbor. So town of Grindavík was built there because there's a good harbor there. And harbors are in some parts of the coast of Iceland. It is not easy to find good harbor either. There are too many loose sediments, but here it was actually the volcanic activity that had built a good harbor. So the origin for the town is a good harbor.
So the earth gives and the earth taketh away. Jenni, glad to have you back. We were just asking, here you are at this Cities on Volcanoes. You can presumably amplify this idea that volcanoes draw, for good reasons, draw people to live near to them.
Yeah. I mean, there's all sorts of things. I'm going to show you something. I tried to show you the volcano, but the Wi-Fi wasn't good enough there. But here we are. You can see now in the background me, and probably here, water. So often in places, there's a really strong association between volcanic landscapes and the currents, really fantastic supplies of water because of the underground relationship between them. So there's many benefits to living in volcanic landscapes. And also the thing to remember is that volcanoes often only erupt every few centuries. So is it so wrong if somewhere only erupts every few centuries that you place your time somewhere which is a really fantastic fishing port, for example, even though it is close to that fisher? So there's all sorts of reasons and trade-offs that people are making with their everyday lives as to why they live near volcanoes. But geology brings us many benefits, and it's particularly true for volcanic landscapes.
I mean, I presume the conversation you're having at this conference is how, with 7 billion people, you live there, but you manage the risk. And I have to say, I'm not quite sure how you achieve that balance, but you're hearing some of that, are you?
Absolutely. And I think one of the things that we're starting to recognise is that we need to think about volcanic risk in the round. And what I mean by that is think about risk from the perspective, the very scientific perspective, but also from the perspective of those people who live it. And what we're learning from them is that there's particular places where we as scientists should really focus. So on timescales, I expect Mike was telling you about Krakatoa and these escalations in activity. So we need to be better at predicting those moments when it becomes too dangerous for people to live too close, and think about the scale over which they have to move, and try to do better at warnings on timescales that mean that they've got the time to do something about it. And then often people want to move back. So thinking about how to manage that, particularly when volcanoes have changed the landscape. One of the things that they do that is amazing is they change the landscape in a minute. So a really large volcanic eruption can do the work of a glacier in minutes. It's incredible in terms of changing the landscape.
I mean, we saw that in, you'll have to remind me of the name, in Tenerife, in the Canary Islands. There was part of one of the big islands there was completely resurfaced.
Yeah, La Palma. Yeah.
La Palma, yeah.
Yeah, that was a fairly recent eruption, and again, it was something that there'd been earthquakes there for several months before, but we hadn't seen an eruption in La Palma for quite a long time. So it's one of these things, just as Jenni was saying, is that you can live beside one of these volcanoes or on those islands and actually really not witness any eruptions or any mal effects, but actually, you have to be a little bit unlucky sometimes to have some of these eruptions where they are.
I mean, complete farms and villages and so on. Yeah.
So how do you actually harness the power of the volcanoes? Because obviously there's lots of people living around them for lots of good reasons, but tell us what those reasons are.
Maybe we should ask Freystein. How do you harness the power there?
Actually harnessing the geothermal areas on volcanoes is one of the fundamental pillars of the economy of Iceland. So we have several pillars of economy: fishing, tourism, and actually partly for heavy industry. But heavy industry is powered by green energy, either from waterfalls and also from geothermal. And the geothermal, it is maybe the biggest change when I think of how living conditions here were 100 years ago. We heat all our houses very easily in the winter time, in the cold Iceland winter, and it's a lot of heat. preferably want to wear just t-shirts in our houses in the wintertime. Lot of heat. It is maybe the only thing that's relatively cheap in Iceland because everything is expensive. So it makes life, it adds a lot to the quality of life to have this. And hot water, so they link the magma fuels geothermal systems, and we can utilize geothermal systems. We need also to be careful to respect the value of the beauty of nature and preserve some areas just to enjoy them, have them. So there is a dilemma how much we should use and how much we should just secure sort of wilderness and undisturbed geothermal areas for the future benefits also of mankind to observe and enjoy the beautiful places on volcanoes.
I was in Reykjavik several decades ago, Freystein, and the things, some of the things I remember were you'd have the manhole covered in the middle of the streets, and steam was coming out, and that was from the way that you move the geothermal heat round to all the bathrooms, houses, but also the bath had a sulphurous yellow ring around it because I think the water was straight from the. Is it still like that?
Only in some parts. There are some problems, or it is. There's a lot of engineering that is needed to utilize this in a good manner, and there can be a problem if we take geothermal water and we put it into pipe that. There will be scaling or silica that will in the end clog up pipes. So one solution to that is to have water without the sort of chemicals from the geothermal systems in it, heat up cold water and pump that to Reykjavik, and that is mostly being done now. There are only few sort of suburbs here of Reykjavik that directly get the geothermal water. Most of it is cold water that is heated up, so it is not the same problem. So there are technical advances. It won't smell
the same either.
No, the smell has gone also, so there is less of a smell. So this, so it has changed. Come again. But we have, for example, in this area at the volcano, we have the Blue Lagoon. This is we can say a geothermal resort. Taking a bath in geothermal water can be a fantastic experience, and the Blue Lagoon, in this very center of activity now, is the biggest tourist attraction in Iceland. The tourist agency tells that about 50% of all tourists that come to Iceland, they are coming to Iceland to see the Blue Lagoon. So it is has an immense attraction, just taking a bath in geothermal water.
Geothermal is something I think that's really interesting. You're going to hear a lot about geothermal in the next sort of decade or two, because it's now been known, and as we try to decarbonize our economies, the ideas that we've got from Iceland and these volcanic regions are now being spread to other places in the world where we're using the ideas of drilling down to kind of hot areas in the crust, but if we drill deep enough, actually, because of the Earth's geothermal gradient, then we'll reach hot crust anyway. So what people have started to do, in Cornwall, for instance, they've started doing this. Also in the US, they've started to drill down to about 5 kilometers underneath the crust, and they're reaching hot crust. So you can pump down cold water, as Freystein was saying, and then you heat up that cold water, and then it shoots up another pipe where it's really, really hot. And so this gets quite interesting. So there's that development. And then there's also a development that if we drill even closer to the magma, then we can get something what we call supercritical geothermal. So this is like 10 times the energy that you get from conventional geothermal. And this is something I would say Iceland are the world leaders at the moment. It hasn't been imagined yet, but it's something that's going to be happening perhaps in the next few years.
Yeah, I can vouch for that. I was just thinking it's such an exciting example of international scientific endeavour. So I predominantly work on volcanoes in the Eastern Caribbean, and I've met Icelandic scientists there, working together with the people on those islands, which all have fantastic geothermal potential, with tapping into that potential. So kind of that expertise is something that conferences like the one I'm at is where we kind of share ideas, but we practically go out and do this. And geothermal is a wonderful example of where we have some real solutions to offer. And by sharing across borders, that's where it becomes, it really starts to realise its potential, Mike.
I mean, you say that this is a potential in the Caribbean. I'm trying to think which island it was which was erupting the first time I spoke to you, Jenni, in the Caribbean, and there were big problems that you were dealing with at the time.
Yeah, it was Soufriere St Vincent actually, and we passed some of the test drill sites. Actually, it's where we gathered some of the ash, so there was huge amounts of ash, and there was a lovely flat surface because of the geothermal test site. So it was really useful for us in terms of working out what had happened with the volcanic ash. But yes, it was St Vincent that erupted in 2021 at the height of the pandemic.
And one of the questions I wanted to ask you, because you're saying how there's good reasons for building cities in these places, but one of the things is with population growth, those cities, can you hear me, I hope? Those cities are getting bigger, and I think quite often people are no longer living in what could be considered safe zones.
Yes, and I think there's some really important considerations and why it's useful to start thinking about these populations, because what's very true is that often the more highly prone zones, often in these volcanic landscapes, there's some places where you can live, but there's very, very steep slopes, and it's often marginalized communities. So a lot of the inequalities that exist in populations, so some people have more wealth and access to services than others, are often amplified by the volcanic risk that they place themselves in because of where they can find a place to live.
I mean, I remember seeing a paper, and I found this quite scary. I think it's in Peru. I think it's a town or a volcano called Arequipa, and that what's happening is that the new buildings, the new houses are being put further and further up into the area where in the past big landslides have come down with these big pyroclastic flows and so on. So
it's interesting. So it's the town of Arequipa, and the volcano is called El Misti. It's a huge volcano, and it's like it has very steep slopes, and the town is basically built on past flows because it's a good place to be. And if you visit the town, it's built of beautiful building stones that are made from these deposits that have come from the volcano, and it has a lot of cultural significance too. But yes, as things expand, they tend to spread along and upwards. And so that's something that's a really important challenge. And then, of course, the complexities of getting people out in a hurry kind of magnifies and gets much, much greater as you go along with that. So thinking carefully about how people can get out. And it all comes down to timescales, doesn't it? How much time we need, how much time the scientists can provide warning in which people can get out. And that's a really important conversation that we need to keep developing.
Fraser, I mean, that's quite interesting. There are sort of two questions. One is, you said that the warning in Grindavik, I guess you got these rumblings that went on for a week or two, so a bit of sort of seismic activity that told you something was coming up. But I don't know, how smart are you in Iceland? Because if anyone's going to be smart, it's going to be you at anticipating correctly when the kind of eruption is going to happen, but also what type of eruption. I'm thinking of the 2010 eruption, which I cannot pronounce, which shut down European airspace. So you can help. But I mean, did you have any idea that was coming? Just give me a sense of how clever.
Yeah, well, I'm not sure how clever we are. We have developed this town in a major hazardous area, but the eruption that closed the airspace, Eyjafjallajökull, that was the name of that volcano. In both cases, there had been unrest, and we can see it rumblings, seismicity, but also, and what my specialty is to measure the ground movement. We can use various techniques to see, for example, how the ground is uplifting. If it's uplifting, it is often due to pressure increase. So we can relatively easily, even worldwide, where there is some monitoring, tell where there is volcano unrest going on, because we see it in increased earthquakes, this uplift or new volcanic gas coming to the surface. But telling exactly when a volcano will erupt and what kind of eruption it will be, that is difficult. For type of activity, we often look at the geological history and see what has been coming out of this volcano. That can give an indication, and was, for example, the reason why in the eruptions in the last few months in Iceland, we have been expecting eruptions to produce lava. But we can use these maybe to try to give a warning on this timescale of weeks or even months in some cases. Use this ground uplift because sometimes we can have a way to tell what is a critical level. So, for example, the eruption last week in Iceland was forecasted. And there was a time window of about 4 days where we could evaluate, or the scientists here at the Icelandic Meteorological Office could evaluate that enough magma had accumulated inside the volcano such that it was equal to the what was expelled out of the volcano in a previous eruption that was in January. So sometimes it's like a drop in magma pressure and we need to build it up to a certain level. The issue is this level can be very variable and can change with time. So this does not work in all time.
I mean, the 2010 eruption, it was because it was putting grit, dust up into the atmosphere that made it unsafe for... Did you have any idea that it would be that kind of eruption before it started?
We had some, it was a possible scenario. We can often look at scenarios. We know there had been explosive eruptions before in the summit area of the volcano. And we knew actually, we had very good record of the reawakening of the Eyjafjallajökull volcano. It was actually happened over a long period, but there were some new magma coming in, more and more earthquakes. And in particular, in the last 3 months prior to the activity at Eyjafjallajökull volcano, we could see lots of earthquakes and this uplift. We had actually 2 eruptions. One that you maybe didn't hear much about outside Iceland because it was effusive. If it is not influencing global population, you don't hear about the activity in Iceland. But the second one, the explosive one, came from the summit, and there were earthquakes then in the last 12 hours that were very indicative that something was breaking. So each volcano is different, each eruption is different. One needs to evaluate typically evidence from various sources to be able to forecast an eruption.
I mean, Mike, one of the questions, the big questions is, it's all very well to know that an eruption may be coming, and you may be able to evacuate a city safely, and hopefully you can go back and live there afterwards if things aren't too bad. But it seems to me we're pretty limited in terms of what we can do otherwise. And if it's going to be an eruption like the 1784 one you said, which bathed Europe in hydrofluoric acid, maybe I'm over dramatizing it, but I wonder what else can we do?
Yeah, I mean, I think there's a lot still we can do in that space, and just an example of that, we're only monitoring 30% of the world's volcanoes, so we're still far from getting to that point where we're able to give early warnings to all the kind of people that live next to volcanoes, and we're talking about something like 800 million people who live in close proximity to volcanoes. So there's a lot. 800 million people live within 100 kilometers of volcanoes.
Right.
So there's the stat that often gets kicked out.
Yeah.
So, there's huge amounts we can do. There was a huge eruption in Tonga in 2022, just a few years ago. And it was very similar to that 1883 eruption that you were talking about. And it also sent these shock waves around the world. It created a tsunami that actually killed some people in Peru, so quite far from Tonga. And so what I'm trying to say is that volcano itself was the closest seismometer, and the seismometer is one of the main instruments that we use to measure the earthquake activity before those eruptions, that was 750 miles or 750 kilometers away.
Did anyone suspect that it was?
Well, it was erupting in a very semi-explosive way.
Right.
So it was erupting, and people, the Tonga Geological Services there, they were kind of monitoring it visually. But they had no idea that there were these kind of magnitude 4 or 5 earthquakes going on underneath that volcano. And if they knew that, so we only understand that by looking at these seismometers from Fiji, 800 kilometers away, and we can retrospectively see that there was these really large earthquakes going on underneath the volcano. But if the communities knew about that in advance, then they could do a lot. But I also sense that the leading question there was that is there a way to potentially manipulate volcanoes as well? And that's a conversation that often gets mentioned or asked about in a public talk, but volcanologists generally don't talk about it very much. And I think that perhaps we will start talking about that more in the future. If actually drilled into magma by accident about 5 times in our history, some in Iceland, some in Kenya, and other places as well.
What happened?
Well, maybe Freystein will know more, tell us more, but essentially the well got destroyed, the drill bits got destroyed, and there was some ash that came out of the drill vent. But essentially no kind of major eruption. Yeah. So that brings the question is, well, if we can technically access these magma reservoirs, should we or can we do anything to...
You're talking about sort of depressurizing them, letting a bit of steam off safely.
The idea is out there. I think actually this hasn't been discussed much in the volcanology community. Whether we should or not, I don't know, is the question. Certainly not in the short term, but perhaps there's...
Go on.
Yeah, I interrupt you to say I'm definitely not in the I don't know category. I think there are many other things that we could focus on that would provide really great leaps for understanding. Before we do something, spend a lot of money doing something like that. And I think the things that you mentioned as simply as putting instruments down, the kind of instruments that Freystein works with, where you can use satellites, you can cover many more volcanoes around the world, and using those to understand the volumes of material that are moving around, I think is where we can really make huge inroads into kind of understanding it by diagnosing what's going on in the undersurface. Sorry, Mike, I
100% agree with you, 100% agree with you.
Well, I'm curious, I mean, Freystein, in Iceland, in Grindavik, you've done one very basic bit of geoengineering. I've seen the videos of bulldozers trying to redirect the lava, which is a pretty simple measure you can do.
Yes.
And it works.
Sometimes. The geoengineering, well, we have this project here in North Iceland at a volcano we call Krafla, where we actually want to drill into magma on purpose. It can give lots of benefits to do it in a controlled environment where we are not having unrest, because we can learn a lot about the generation of energy, more geothermal energy. We can have wells that are more powerful. We can also learn a lot about the interface from the solid rock and the molten magma, how it is in action, and we can even try to put instruments into the magma, and this is all goals of the Krafla magma testbed. We need to see how that evolves, if that will turn into a reality. But
tell me more
I think
about this.
we cannot do it on a general scale, but we can do it in a testbed.
How far down are you going to go? What kind of drill bits do you need that are going to survive the heat? I mean, this sounds pretty exciting.
Yeah, 2 kilometers. It is best to do this in a place where we know where the magma is. And we have had this accidental drilling into the magma. If we want to drill into magma on purpose, the idea is to drill down there, and then you would solidify a little piece of the molten magma and drill into that to better understand. This would be a science project. Maybe it will end with nothing. Maybe it will fly if we find funding for it. But we think we can do it in a safe manner and learn a lot about the the origin of geothermal energy and how to best use it, and hopefully gain some experience to utilize, to understand hazards from volcanoes and other parts of our planet.
What about the safety? I mean, you must be doing a risk analysis to make
Yes.
sure.
The suggestion is we can only do this in areas now where we know that we have magma and it is not under too much pressure. So the magma that was drilled into, in a sense, it has been done actually more than often in this geothermal area. And this magma is of very different types. Some is very, if you think about those persons, very energetic and just want to go out and run if they can. But this magma that has been drilled into is kind of lazy and wants to lie around. So we think we can we can go and learn something there, like having it as a laboratory.
Yeah.
But not for the general. We need the techniques Jenni was telling us about. Using satellites is, of course, wonderful because we can have satellites circling the Earth and collecting a lot of data, and there is a big expansion in use of satellite data. The issue is, one of the critical things to monitor volcanoes is to understand the earthquakes, the seismicity. We cannot do that from space. We need the instruments on the ground.
And again, that's where I think Iceland is so different to the big cone-shaped volcanoes
Yes.
that Jenni's nearby. Jenni, I mean, I just want to check, you're happy with Freystein doing this, are you?
Yeah, I 100% approve of what Freystein's doing, because what he's doing is trying to use it to understand better some of the systems that we could then apply worldwide. I think crazy scientist expeditions in to release the pressure. We could spend so much more money just putting seismic instruments down and understand things so much better.
I mean, if it works, are there any volcanoes you'd like to drill into? I mean,
Oh my word! I think that's a really interesting question to ask any volcanologist. If I could give you £1 million, what would you do? And I guess my answer is I wouldn't spend it drilling into any of the volcanoes that I work on. I very much enjoy coming to see the really incredible advances that they've made in Iceland with what they're doing. But I think I would spend my £1 million differently.
Okay. I just want to come to one other thing. Something else which happened with the Tonga eruption a couple of years ago was Tonga itself got, I think, disconnected from the rest of the world.
Yes.
Because it had fibre optic cables, and the whole world is connected by fibre optic cables. And I think this is one of the global things that you're concerned about.
Yeah, I mean, there's just a whole bunch of sort of critical infrastructure that powers our global world. 99.9%, I think, of our internet comes from submarine cables that go throughout the ocean. It's quite scary in some ways. And but they are susceptible to things like flows, things like earthquakes, or even volcanic eruptions that commonly will break these sort of cables. And we saw that in Tonga, for instance, it only had 1 or 2 cables that connected it to the world, and that connected its internet and things like that, and they were severed, and that caused big problems. So that's just one sort of critical infrastructure, but it could be on a sort of a grander scale. We saw some sort of large eruption occurring in an area of dense critical infrastructure, somewhere like the Mediterranean or somewhere like Southeast Asia, where you don't just have these submarine cables, but you also have things like the marine trade, essentially, or big seaports. And sometimes these are, associated, some of these channels are associated with shipping a huge amount of our energy via kind of oil and petroleum, but also our kind of everyday supply needs that we need, or food. So I think there are problems that we can get from smaller eruptions, and we saw that with Eyjafjallajökull. I'm not going to try and pronounce it in front of Freystein. Eyjafjallajökull, there we go. We saw that in 2010. It's not a very big eruption on geological time or scales, but actually it was very directed towards that airspace, that very busy airspace that we saw over Northern Europe.
I mean, has anyone done anything like what happens if, let's say, Tambora happened in the 21st century?
There's been a few
Sort of
studies.
scenarios, yeah.
Not too much, I guess.
Really?
Yeah. Jenny, would you like to add something here?
There's something that we would call counterfactual analyses, which is a really powerful way, and it's something that we do naturally just as scientists when we're meeting at conferences like this, is we do what-if experiments. And we can do what-if experiments in a formalized way, and it would involve exactly things like that. What would happen if we had, and then we have all the geological information that we can bring together, plus all the information that we have about the infrastructure as it exists now. And that's something that some volcanologists are starting to do. I'm all about turning the negatives into the positives, though. So just to come back to your fiber optic cable, I know you like a bit of technology. It is really vulnerable to these flows, and Mike is absolutely right. But it also offers us another thing like satellites that has a potentially global solution. So fiber optic cable as well has all these little imperfections in it, and something that seismologists are starting to do is use those to kind of understand and monitor the environment. And I believe had some fiber optic cable monitoring out on Iceland already, Freystein, I think.
Yes, we have. It is providing valuable information, but there is still work to sort of extract all the information and understand what it really means. But
Yep.
they are there in the town of Grindavik and nearby, actually, as we speak, recording and checking the conditions. But I think there's a lot to learn yet.
Yeah. So that's something that we can all kind of work on to improve the network, and the more we have data, the more we can understand. So we need to look after the fiber optic cable for lots of reasons.
That's brilliant. Our hour is up. Jenny, I just want to ask, have you done any of the local volcanoes while you're out there? Or are you going to? Are you going to hop up?
So just to encourage any of your audience who are thinking about becoming a volcanologist, when you go to volcano conferences, we always have field trips in the middle. And I had a wonderful opportunity on Wednesday to walk up the Pacaya lava flow, which erupted in 2021. And it was kind of special because obviously I was working on St. Vincent, a completely different style of volcanism that happened at the same time. And this was a lava flow that didn't cause any disruption to the local population directly. So it was it was really fantastic. So I've been to Pacaya, and of course we can see fuego erupting every few minutes. We can see the red in the evening as we're relaxing. So yes, I have.
Very sad. When are you going out to Grindavik again? Do you go out there regularly? Do you do it all from your office?
Most from my office. Not very exciting. But so my work as a geophysicist, we have instruments, and because of the high activity at Svartsengi, we have automated a lot of the data transmission of instruments. So the data is coming just into our office, so we can monitor it more easily. But for any person studying a volcano, it's very important to put in context. So I go out. It is just not as frequently as Jenni. But if we don't go out, we cannot have the context. We need to see the volcano. We need to understand the geology, even if we are working with other details like seismicity. Otherwise, there is the risk that we come to wrong conclusions, I would say.
Mm. You travel quite a bit, Mike, don't you? Where's your next?
Not as much since having kids, but yes. Next trip, I go to Indonesia quite a lot, and Indonesia is a place with one of the most densest populations in the world, but also one of the densest volcano populations in the world. So it's a place which is very vulnerable to those risks.
And pretty exciting to go to, I suspect.
It's an exciting place to go to.
Beautiful.
Beautiful.
I mean, I suspect it's beautiful because of the volcanoes.
Exactly, yeah. Beautiful and populous probably because of both those aspects, yeah.
Well, thank you all, Freystein, Jenni, Mike. Thank you so much. Big round of applause then, please.
Thanks.
And I think if Mike's got a couple of other samples of rocks here, I'm sure he'll happily talk people through those.
Thank you.
Thank you.
Thank you.